Welcome to Spring LIB.
Hi, today we're going to be talking about a problem where we have a alarm clock which is moving in angular simple harmonic motion. So the first thing we're going to do for this problem is realize that 4 ticks per second at one cycle being 2 ticks gives us a period of 0.5 seconds. We're going to change the radius into meters and the mass into kilograms just so that everything works out well with SI units. So the first problem is asking us what the moment of inertia is. So we look at the disk and we're going to call it a thin, we're going to look up the moment of inertia for this object, and we're going to have that I is going to be equal to mr squared for a thin hoop. So we're just going to basically plug in these values, and we're going to end up with I is going to be equal to 2.7 times 10 to the negative 8. It's important always to remember units, and this is going to be in kilograms times meters squared. Excellent. Let's move on to part B. Part B is asking about what the frequency is going to be, or rather the torsion constant is going to be. But we're going to get there from the frequency. So we're going to look at this, and we're going to say that we have the period, which means that we know the frequency. So we're going to say the frequency is going to be equal to 1 over 2 pi times the square root of k over I, where k is that torsion constant that we're looking for. And we can also say that this is equal to 1 over t, 1 over the period that we already have. So once we rearrange all this, we end up with an expression that is the spring torsion constant, k. It's going to be equal to the moment of inertia divided by the period squared over 4 pi squared. Basically, you're just going to plug all that in, and you end up with the torsion constant is going to be equal to 4.3 times 10 to the negative 6th. And the units on this one, if you look at it, are going to end up being newtons times meters divided by radians. Thanks for watching, and I hope this helps.